In this lesson, you will learn how to factor the difference of squares. The rule we will use for factoring difference of squares is a squared minus b squared equals, our factored form will be a plus b and a minus b. In order to factor a difference of squares, you must have a binomial, so meaning two terms, with a subtraction sign between the terms. That's what difference means, is subtraction. So you must have a binomial with a subtraction sign between those two terms. The first and last term must also be perfect squares. So that's why we see here a squared, so it's going to be something squared minus another perfect squared, a b squared term. So let's look at some examples. We have x squared minus 225. So this is in the correct form. It is the difference, there's a subtraction sign, of two squares. Both of these terms are perfect squares. So in order to solve in order to factor this problem, we will first begin by taking the square roots of the first and the last term to determine our a and our b value. So to get our a value, we're going to take the square root of x squared. So the square root of x squared is just x. To get our b value, we're going to take the square root of 225. You should know your perfect squares, but if you do not, just use your calculator and punch in second square root. It's the square button in that same column where the second key is. Look for that square root in blue. So hit that x squared button to get the square root symbol. So second square root 225 is 15. So our b value is 15. So we're going to follow the rule of a plus b and a minus b. So your a and b are x and 15. X and 15. Set up your parentheses where one has a positive and one has a negative. And that is the factored form of this problem for difference of squares. Let's look at another example. Here we're going to have 144x squared minus 49. Again, it must be in the form of difference of squares. So look for the subtraction sign with the perfect squares. 144x squared is a perfect square and 49 is a perfect square. So we're going to take the square root of each of those terms in order to find our a and b values. So the square root of 144, again, it's good to know your perfect squares. The square root of 144 is 12. Don't forget your variable. The square root of x squared is just x. So then for the square root of 49, that is 7. So our a value is 12x, our b value is 7. So set up your parentheses, 12x, 7, 12x, and a 7, with a plus and a minus sign in your parentheses. It is also okay when writing your parentheses, because multiplication is commutative, meaning it does not matter the order that you multiply in. You could say 12x minus 7 and 12x plus 7. Either answer is correct, the positive negative or negative positive. Let's look at example number 3. Here we have x to the fourth minus 256. So let's look to see, this is still the difference of squares. We have a subtraction sign. X to the fourth is a perfect square. Anytime your exponent is even, it is a perfect square. Because you're asking yourself what times what equals that term. So we can, when working with even exponents, say that those are perfect squares. 256, let's check it. The square root of 256, that one is a perfect square. So we're able to work this using our rule. So a is going to be the square root of x to the fourth. b is going to be the square root of 256. We just found that the square root of 256 is 16. So the square root of x to the fourth, if you need to, go over to the side and write out those 4 x's. And because we're talking about square roots, you're going to be looking for pairs. So we actually have 2 pairs, x times x, which ends up being x squared. So when taking the square root of a variable, you can just take half of the exponent. That's why all of your even exponents will be perfect squares. So x squared is our a value. So let's set up our difference of squares factored form. So we have x squared plus 16 and x squared minus 16. But don't stop just yet. This is the difference of squares. So because we still have the difference of squares in our problem, we have to completely factor in order to be done in our factoring. The first parentheses is the sum of squares. We'll look at that in just a moment, but the sum of squares cannot be factored. The difference of squares can be factored, as we just talked about. So we'll have to find our new a and b values. So a is going to be the square root of x squared. B is going to be the square root of 16. The square root of x squared is x. The square root of 16 is 4. So the first parentheses, it has to be in your final answer. We have x squared plus 16. The second parentheses is the difference of squares, so it can factor with the x and the 4. So we have x and 4, x and 4, and put your plus and minus sign. So always look for the difference of squares. Even when you factor, you may have to factor again if another difference of squares is in your work. So let's look at this one to see. X is not a perfect square, even though we have a subtraction sign, and yes, 4 is a perfect square, but because this term is not a perfect square, we cannot factor this one any further. So this is our final factored form for our original problem, x to the fourth minus 256. So let's look at the sum of squares. If we took maybe x squared plus 4, can that be factored? X squared plus 4. Well, let's just try first of all what we've been doing, where we take the square root of first term, take the square of the last term, and make our parentheses. So that would be x plus 2, x minus 2. And we can check that by distributing it back together. So let's try x times our x minus 2 and 2 times our x minus 2. So distribute it back together, and if it works, we should get back to our original problem. X minus 2. So x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. And I left off my exponent. X times x is x squared. Always go back and check over your work. So notice here, the negative 2x, positive 2x will cancel. So we have x squared minus 4. That was not what we originally started with. So these are the incorrect factors for that binomial. So let's say, well, maybe if it's not plus and minus, maybe they need to be both plus signs. So let's try this one. What if we say x plus 2 and x plus 2? So let's distribute this out to see if it will work. So do your x times your second parentheses. Do your 2 times your second parentheses. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. This time in the center here, we can actually combine our like terms, and they do not cancel. So we get x squared plus 4x plus 4. So this time we had our x squared and our positive 4, but we ended up with this middle term that we don't have in our original problem. So again, no, This is not a factored form. Well, we might as well just try the only other option with having them both negatives. So let's try x minus 2, x minus 2 to see if that will work out. So set up your distributive property. And x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. So notice in the center here we have our like terms. They will combine, they will not cancel. So again, we get our x squared and our plus 4, but we end up with this middle term that needed to go away. That would not do that. So again, no, this does not cancel. So when working with the sum, meaning a plus sign, of perfect squares, we cannot factor it. We call these prime. Prime means that it has no other factors than 1 and itself. So the only way to really factor this is 1 times that same thing. It is a prime factor. It is a prime problem as far as factoring. There is no other factors than 1 and itself.